Hello, we are Team 10 and our project is about RL for one-on-one game involving strategy and mind games. Our problem is competitive, partially observable games for RL. It's challenging because information is limited and agents have to estimate the hidden states by opponents' actions. Studying these games is considered as an important problem since most games in the world are partially observable. In our project, we chose India Poker, which is a simple card game that a player can see the opponent's card but cannot see their own card. Player who has higher card wins the pot, and players should bet or fold according to partially observed information. In this project, we have two approaches, self-play and opponent pattern analysis. In self-play, agent is trained by competing against itself, expecting better training data. In opponent pattern analysis, the agent analyzed the opponent's action pattern for better performance. The first experiment is about self-play. We trained some agents against random agents, as usual, and others against itself by copying parameters. To evaluate the performance, we implemented three RL algorithms, DQN, NFSP, and A2C. The agents compete against non-self-play agents to compare their win rates in both episodes and rounds. Next, we experimented opponent pattern analysis. Here, the agent observed opponent actions such as betting patterns and uses this information to estimate its own hidden cards. The figure illustrates an example scenario where the opponents choose to raise pot. Then the agent estimates its own card inside the red box and selects its action. We used the same algorithms in the previous experiment. We also compared the performance of pattern agents with non-pattern agents and measured episode and round win rates. These are the results for self-play experiment. Overall, self-play agents achieved higher win rates compared to non-self-play agents. Especially DQN plus self-play model showed the largest improvement in win rates. On the other hand, self-play didn't improve the NFSP's win rate, but maintained it around 50%. Next, let's look at the effects of opponent pattern analysis. For agents trained against random agents, pattern analysis didn't work well. Our teams think that this is because the random agent's pattern is not helpful for the agents. On the other hand, in algorithms trained by self-play, pattern analysis improved win rates except A2C algorithm. To identify the best policy, we compared three best policies in previous experiments. The chart shows the episode win rate and round win rate of the left agent. As a result, DQN with self-play and pattern analysis was the best, and A2C with self-play follows. These are our conclusions. First, self-play combined with opponent pattern analysis is the most effective strategy by our project. Actually, the best policy in our project was DQN with self-play and pattern analysis. Lastly, here are some limitations of our project. First, NFSP algorithm showed stable but low performance with self-play, and A2C algorithm struggles with both approaches, self-play and opponent pattern analysis. Second, opponent pattern analysis got struggled against random agents, so it needs to be used together with self-play. Finally, our pattern definitions were too simple, so more sophisticated pattern definition is required for further improvements. Thank you for your attention and have a nice day. Thank you.